Okay, guys, so we're starting our first day in Math 10. Uh, we'll probably, I'm not 100% sure this year how we're going to flip back and forth between grade 9 math and grade 10 math, but I'm going to try to put everything up on Google Classroom this year and see how that goes. So we might bounce back and forth doing one day online, one day off, or something like that. And today we're going to start out with something that you guys were able to work through mostly as an extra unit last year in grade 9, because grade 9 we had a lot of time to get math done, and that's the tangent, sine, and cosine ratios. So we'll start off with tangent ratios. So you can see on screen there we have our goals for today. So we're going to be using the tangent ratio, which is in section 2.1. We aren't going to do section uh, chapter 1 until the end of the term, or we might do it in science. Actually, it's more of a science related thing anyway. So we'll see how that goes. And then we have three goals for today. We're gonna look at the tangent ratio, okay, what it means, and how to use it. Then we're going to do example problems of finding the ratio, using the inverse ratio to find the angle, and then basically look at solving a problem. And then next day, we'd be looking at angles lengths rather than angles. But we're going to start with angles today. So it's to your benefit to have a calculator of some kind uh, with the tangent ratio on it, sine, cosine as well, because we'll be doing those as well. And make sure that it's in degrees, so it has that little DEG at the top when you're working on it. We're going to use degrees always in grade 10. Okay, so let's start off with the basics here. So let me get my pad down here, and we're going to go into slide 2 here. Okay, so if we have, this is always a right triangle ratio. So the first thing we know is that we're looking at right triangles. So if I were to make a triangle here, let's just make a right triangle using the shapes. That this always has to do with a right triangle. So if we were looking at a right triangle, okay, and we put our right angle in there. And now you can use two different angles to reference. Now the 90-degree angle we don't generally use as our given angle. So you can either use the bottom angle or the top angle. And using which angle you use depends on how you label your sides. So if we're using the bottom angle here, we'll call this angle theta, Greek letter. If that's, we label our sides, we always label the side opposite the right angle as the hypotenuse. Which I think we'll just go with the 3. Okay, so that's always opposite of the right angle is the hypotenuse. Okay, the one that your given angle that you're looking at that's opening, the angle's opening up and touching this side or opening to that side, that's called the opposite side. Okay, and the one that includes the leg that's part of the angle that you're working with, not including the hypotenuse, is the adjacent side. So the adjacent side touches the angle. Okay, the opposite side does not touch the angle. Okay, it opens to the angle, and the hypotenuse is across the triangle from the right angle. Okay, so given that setup, we know that when we're looking at tangent, the tangent of the angle theta, which could be any angle, and we're going to only be using 0 to 90 degrees in grade 10. When you get into grade 11, you go into larger degrees after that. And that's going to be equal to the opposite side over the adjacent side. Okay, so opposite side over the adjacent side. Now, if we want to save ourselves a little bit of writing, you could write it with just O and A as well, which is what I'll end up doing quite a bit. Okay, so generally speaking, they'll abbreviate tangent to just tan. And generally speaking, they'll abbreviate opposite side over the adjacent side. So that's our general formula for tangent. Now, if you were to have to find sides, which we'll do in our second lesson next day, there would be a rearranged formula for the opposite side and the rearranged formula for the adjacent side as well. But we'll be focusing on that specifically next lesson. This lesson, we're going to focus specifically just on the angle side of things. Okay, so that gives us an idea of, okay, the first example, if we go back to our opening page, is to look at, now that we know the definition, what is finding the ratio? Well, finding the ratio is quite easy. Okay, so if we look at some examples of finding ratio, okay, so we'll call this find the ratio, or, well, I guess we're not going to say ratio, we'll say tangent of theta. Okay, now this time, I'm going to just draw out a couple triangles here. So let's draw a right triangle again. Okay, this time I'm going to put the tangent. Let's say that this is 6, and this is 4. Well, that looks to be about the same, but we'll say it's 5. Okay, and let's say that we use this angle instead of the bottom one. So that means, okay, this would be opposite of the right. This is our hypotenuse. Okay, opposite of the given angle, this is our opposite. And touching our given angle, that's our adjacent. Okay, so tan theta then is equal to opposite over adjacent, which in our case, we can say opposite is 6 and 5. So there's our answer, 6 over 5. If you do that as a decimal, that's 1.2 as a decimal, okay? Now they usually tell you to leave it as a fraction or round off to a particular decimal. So that's pretty easy to do in that case. Now you're not always going to get this nice even kind of right triangle. So, okay, give yourself, let me draw use the lines here to draw a different one. Let's say we'll put a little border on that so that we know that's on that one. Okay, and I'll draw a new triangle here. Nice long one with a little short side like that and a long side like this. Okay, now let's get tricky a little bit. Let's say find the tangent ratio like this. Let's see if they do that in the book, if they're mean to you or not. Actually, they're not. Oh yeah, they are mean to you. Okay, so sometimes they'll be mean to you. So let's be mean to you here. And I'll give you the hypotenuse instead of one of the other legs, which makes it using Pythagorean theorem first to do it. Okay, so if you have a case where, let's say you're given this angle here is at a right angle in the corner, and let's say that this is tan and that this is 8 here, and they ask you, and that your angle is this little skinny angle here, and they ask you, what is tangent theta? Okay, and then we'll say to the nearest tenth. Well, I bet we better go nearest hundredth, 2 decimals. Sometimes we go to the nearest thousandth even, depending. But we'll say in this case, we'll go to the nearest hundredth. Okay, so first step is we have to label what we know. Well, this is the hypotenuse. Okay, and that's the opposite side. And this is the adjacent side. Well, we can't find we have to first find the opposite side. So we know that the 2 legs squared equal the hypotenuse squared. So if we're using A for adjacent and O for opposite, not theta, sorry. Okay, and then H for hypotenuse, that is Pythagorean theorem written for that particular triangle. So we've got 8 squared for the adjacent side, plus the opposite side is unknown. That's not a 0, that's an O. I should have used some other, let's put a yeah, that's kind of a bad one to use for that. Let's go OP squared so that we don't think it's 0, okay? Because then we get mixed up later when we're looking back. And then 10 squared. Okay, so OP squared by itself. So that's going to be 64 squared plus OP squared equals 100. So subtract 64 from both sides. Okay, and we've got OP squared equals, okay, we're going to subtract 64 from 100, so that's 36. Okay, or sorry, yeah, 36. You can see that I'm just trying to make it even. So then if we square root that, OP, the opposite side, is equal to 6. And we'll put it in a different color, because we figured it out. So now we can do the tangent ratio. So sometimes they'll give you the funny or make you have to use Pythagorean theorem to get that missing one of those 2 legs. So that's going to be the opposite over the adjacent. And then opposite is 6, and the adjacent is 8. And if we do that, that's 0.75 if we do that on our calculator. Okay. Let's make that 5 a little better. Okay, that's our first example, finding the tangent ratio, okay, on there. So that's part 1. So if we look back, I don't want to go too long today. Find the angle with the inverse tangent. Okay, so now we're going to be given the 2 legs and have to find the angle. Okay, so, and notice I haven't done any word things yet. We're just doing diagrams, which we'll get into some word ones at the very end. Okay, so this is example 2, finding theta with, with inverse tan. Now, inverse tan looks like this on your calculator. So if you're looking, you can find the tangent button, and it's right above the tangent button on most calculators. And you'll have to use like your second function or your inverse button, depending on the type of calculator you have. So let's say that we have this triangle here. I'll draw it out. And let's say it looks something like this. And we'll say we label this up here. Let's say that this is our right triangle. This is one leg here. Let's say that this is measuring 106 and that this is only measuring 29. And they want this angle here, which we'll call beta. B with a tail on it. Okay, and I'm going to say find angle beta. Okay, so we're going to look at this and we're going to go, okay, we have to, there's our angle. This is our hypotenuse. Okay, angle opposite of that, oh, that's our opposite. And this is our adjacent. Okay, so we can go ahead and find the ratio of that. So we know that the tangent of this angle beta is equal to 29 over 106. Okay, so if we do that on our calculator, and we're going to use 3 decimals when we do this, so we go 29 divided by 106. Okay, so that's 0.274. Okay, now what we have to do on our calculator, most calculators that are larger scientific ones work forward on this. Smaller, older type calculators or cheaper type ones that, you know, they're just little ones, they will work backwards because they don't have as much memory probably. But that's okay. I'll show you how to use both. I have here as well in my desk an older, oh, that's not it here. There. I have a little older kind of backwards one, and I have a scientific one. So we'll show you how they both work. So we're going to do, to get this, we have to go inverse tan. So this symbol here, tangent with a -1 of the decimal number. How do you do that on your calculator? Okay, if you have a forward bigger calculator, you just leave that, you just have that decimal number point like this on there. And then you type in your inverse button or your second function, depending on what your calculator calls it. Mine's called second function. It's that gray, that orangey kind of button. So then I hit second function, and then I hit the tangent button. Okay, and then I would get equal. Then I get, sorry, that's wrong. I did it backwards. You got to do that for small ones. So you got to go point. Let me do it on the small one first. 0.277 on this small one doesn't work too good. Let's pretend it's 267 is broken. I'm going to throw this one out. Then you'd go inverse 10. Okay, and then you get your answer. Okay, that's for, put that number in, then that for backward runs. If you have a forward calculator, you go inverse tan first. So you do, if you have a forward calculator, you do this first, then you put this in. I'll show you on the big one. So you go inverse tan, and it'll show you that on your calculator. And then you go 0.274 like that, and then you hit equal. And then I get 15.3 degrees. So of course this is going to equal the angle, so we should put that there. So the angle in that case is equal to 15 degrees, or we'll go 15.3. They'll tell you to round off to the nearest degree or the nearest tenth. Most of the time in your book, it's just to the nearest degree. Okay, so that's finding an angle. Let's do one more here quick. And if you want to pause and try it and then unpause when I do, just to give yourself an effort, then you can do that as well. So let's say I have this triangle here. And I'm given this as 18, and this is 15, and I want to get this angle here, Q. Find angle Q. Okay, you can pause there and unpause it when you give it a try, and I'll be working it out. Okay, so if you've unpaused it, okay, you're taking a look here. What do we got? Well, let's see. We got to decide which side this is. This is the opposite side. This is the adjacent side. Okay. Okay. And this is the hypotenuse. Okay, which we don't really need until we get into sine and cosine. So then we're going to write tangent of Q is going to equal the opposite over the adjacent. So 15 over 18. Okay, take our calculator out here. This is 8.3, 0.83, pardon me, 3. If I go to 3 figures, so that means I'm going to go inverse tan of that number. Okay, you could just leave it in a calculator usually sometimes. So that means that's going to give us angle Q, which equals, in this case, if I go second function tan, I get 39.8 degrees. Okay, so that is finding the angle. So that gets us into our last example of the class, and then we'll do some practice. Let me just bring that up so I can see where we are. 20 some minutes, not bad. Okay, so our last example, if we go back here and look, we want to do solving a problem or something like that. So let's move this back ahead. Okay, we'll flip this and we'll solve a problem here. So it could be a word problem, could be a drawn problem. A lot of the ones in your book at the beginning kind of start with just diagrams first and then give you a problem. So let's just do a word problem here. I'll do it in typing. So let's say that a ladder reaches up 1.87 meters a wall, period. If the angle the ladder makes with the ground find the angle, sorry about that, find the angle the ladder makes with the ground if the base of the ladder and I'll try to keep most of our lessons throughout the year around that 30-minute range so that you can do your practice work. Unless we do flipping classes back and forth, then I'll do a larger group of instruction and then have a work day depending on what people like to do. Okay, so find the if the, where was I there? With the ground, if the base of the ladder is 0.85 meters away from the wall. Okay, and we'll go nearest tenth. For our example, so we'll draw this out first. We have our wall and our ground, and then our ladder's in here somewhere. Okay, and then this here is 1.87 meters, and this is 0.85 meters. And we want to find the angle that the ladder makes with the with the ground. Okay, so this is our right angle, we're assuming. So that's this angle here, theta. So this would be our opposite side. This would be our adjacent side. Okay, and this is our hypotenuse here. So tan of this angle theta is equal to opposite over adjacent, which in our case is 1.87 meters divided by 0.85 meters. Okay, so we're going to do that on our calculator. 1.87 divided by 0.85. Okay, 2.2 exactly. That's weird how that worked out. So now we're going to go tan inverse of that number, 2.2, is going to give us our angle at the bottom. So go on your calculator, second function tan of that, and I get 65.55. So we said to the nearest tenth, so 65.6 degrees. Okay, so our angle is with the ground, we'll say, is 65.6 degrees. Okay, so that pretty much takes care of all the types of problems that you're going to see. Now, they do some more examples in the book you can look at, and they kind of use roots as well, but you don't have to worry about roots because decimals will work perfectly on your calculator. So we'll leave ourselves for the last half of class because we got 28 minutes in. So giving you some work time to do some practice. This is on page 75 to 76. Okay, and we're looking at, let's see here. Yeah, it actually goes to 77, but we'll do a couple. So number 3, don't do all of those. They're pretty easy. Just do the A and C part, we'll say. Okay. Number 5, we'll skip 4 for now. 5, you can do A and C again. Let's indicate the measure of each angle to the nearest degree. So nearest degree we're doing. Okay. And then you can do 8. Okay. And then you can do skipping over, we'll flip over here. 10. Okay. When they mean angle of inclination for number 10, they mean the bottom with the ground, the angle with the ground. That's what angle of inclination means for number 10. Okay. We're going to do those 2 of those as well. We don't need to do all of those. And there's some word problems in there you can try. Let's try. Let's try 14 and 15 for word problems. So that'll give you enough practice, and then you can check the answers in the book. Okay, and that's our lesson for our live lesson, or our recorded lesson for today. Unless you're doing it live, depending on how we're flipping, and you should be able to do it. So if you get done things, obviously you got a little bit of free time, but make sure you're doing your practice, make sure you're trying and doing due diligence. Then when you're done, I don't mind if you're quietly working on something else or doing something else, as long as you've asked the questions that you have needed to ask already.